So in this video, I want to do just a couple examples of the binomial distribution. Please make sure you've watched the overview or you already know what a binomial distribution is before you watch this. So I'll just do two quick examples. So here's one example where we have a fair die that's tetrahedral, and that's just a fancy way of saying that there are four sides. And let's just toss it 12 times. Let's find the probability that the number, um, let's look at the probability that you get an even number on it exactly 3 times. So let's find the probability that x is exactly equal to 3, where x means an even number. And so if I see a tetrahedral die, I'm assuming that means that we've got 1, 2, 3, and 4. And so that means that we've got a probability of getting an even number half the time and an odd number the other half the time. So this is a binomial variable where we have 12 tosses with a 1/2 probability of getting a toss. So I know that the probability that we'll get 3 even numbers is equal to 12 choose 3 times 1/2 to the 3 times 1/2 to the 9. Because I need to get here, these are my 3 evens, these are my 9 not evens, and this represents the number of combinations that make that. So again, it's all just, you can type all that into your calculator now, that 12, and then to get to the choose part, remember you hit the math button here and go over to the probability menu, option 3. So 12 choose 3, then you go 1/2 to the 3rd, 1/2 to the 9th. So your calculator should look like this. Hit enter, and you'll get this probability. So about 5% of the time, so 0.054, about 5% of the time, you're going to get exactly 3 even numbers and 9 odd numbers out of it. Okay, let's look at another example. You can use binomial distributions to represent all kinds of things, like, for example, uh, let's say that you know that your car is going to break down on any given drive. You know, some of us have very unreliable cars. So let's say that your car will break down 10% of the time, and you have to drive to work 5 days a week, just for examples here. If that was my example, that your car breaks down 10% of the time, drive to work 5 days a week. Let's find the probability that your car is going to break down 2 or more times in the week. So there's 2 ways you could do this. You could find the probability that it breaks down twice, 3 times, 4 times, and 5 times. Or you can realize that's the same as the complement of it breaking down not at all or once. And so a lot of times when you're doing these problems, there's 2 ways to do it. There's a way to calculate directly the probability you're asked about, or calculate the complement of it. So I'll show you that. This is going to be equal to 1 minus the probability that it doesn't break down and the probability that it breaks down only once. So that's less work, because rather than going 2, 3, 4, and 5, calculating 4 binomial probabilities, I'm just going to calculate 2 of them. You could do it the other way. It's good to double check that it works out the same both ways. So here we have a binomial distribution, right, with 5 trials and a 10% success. And it's weird to call it a success when your car breaks down. But the way I defined X, that's how we're using that term success. So we have 1 minus 5 choose 0, 0.1 or 0.10 to the 0, 0.9 to the 5. I hope this makes sense here that 5 choose 0 is equal to 1. There's only one way to choose nothing. 0.1 to the 0 is also equal to 1. So really, if your car doesn't break down, that's a 90% chance each day. So you go 90% times itself 5 times. For the probability that x equals 1, you do 5 choose 1. So there's 5 ways to choose one of the days for your car to break down. That's going to happen with a 0.1 probability once, but that means that the other 4 days all had to happen with 0.9 like that. So this is just a big long thing to type into your calculator. I'm going to cheat a little bit because I know what the combinations are. 5 choose 0 is just equal to 1. So I don't even need to type the 1. So I'll go 0.1 to the 0. I guess I don't need to type that either. 0.9 to the 5. Minus 5 choose 1 is the same as 5. 0.1 to the 1. And 0.9 to the 4. So here's my calculator. Hit enter. 1 minus that 0.08146. So what this means is that 0.08146. So there's about an 8% chance that your car is going to break down 2 or more times in the week. That means I can also tell you the opposite. If I subtract that from 1, then I know that there's, just about a 92% chance that your car is only going to break down once or 0 times. And so the binomial distribution is really nice because you can calculate for a single value like I did with the tetrahedral die, or you can calculate for a group of values like I did with the car breaking down. So please, please, please ask questions and comment if there's anything that you need help with. In the next video, I'm going to talk about expected value and variance for a binomial distribution. All right, thanks for watching.